This presentation is just going to be a demonstration on Corrosion Djinn Standalone and Siemens integrations, particularly focused on the NX product. Corrosion Djinn Standalone is the hosted on-premise version of Corrosion Djinn. This version particularly needs to be hosted on a Windows server alongside a SQL Server or a Postgres database. It features the same capabilities as Corrosion Djinn, with one-dimensional galvanic corrosion risk analysis, increased fidelity with material area ratios, and then allows the user to manage their own material and coating data, including the polarization data for any environments they create on their own, or existing environments such as the 3.5% or the mill standard environment. Additionally, in this demonstration, we'll be going over exporting data to be used directly inside of the NX and the Star CCM Plus applications. When it comes to managing material data, the users have the ability to add their own materials and coatings. There are lots of fields available for users to add their own data to, including density, UNS, and CAS registration numbers, as well as compliance information, specifications, and supply details, of which some of these fields are exported automatically into NX where an appropriate mapping exists, such as the material's density. There is a required field for corrosion analysis called electrochemical equivalent, which is a calculated field that requires knowing the material's alloy's percentage combination of elements, the density, and the valency of those elements. This will be a calculated field, which in a future version of Corrosion Djinn will allow you to do it inside of the system as well. When it comes to the polarization data and any environments they're related to, users have the ability to create custom environments. This could be a real-world location environment, or it could be related to, for example, an ISO standard, such as a 9227. The system accepts polarization data in the form of voltage versus current amps per meter squared in current density. The actual process of gathering polarization data is quite a complex process that requires specialists. You have to clean the data and then deconvolute it to be mill standard compliant. This is the service that Codata offers within our labs if you don't have the capabilities in-house, which is useful if you have custom materials that can't be shared with the public, or you need this data locally and privately. Finally, we'll be looking at exporting data from the Corrosion Djinn Standalone. This allows you to export your material data and polarization data to be used inside of NX or CCM+. You'll be given 4 files: the license file, which is an encrypted file which contains your colorization data and your material data to be read inside the applications; a coatings and substrates file. These are mat.ml files, which are designed to be read inside of NX for assigning the materials and the coatings; and finally a codata.mdv file, which is a material database file used inside of CCM Plus when you are selecting materials into the surface materials section. For this portion of the demonstration, we'll be looking at the Corrosion Djinn Standalone platform. Here I will log into the system. This is being hosted locally on my desktop. Here you agree to the standard Corrosion Djinn screen you can see when you log into the software as a service. Here I can just do a regular analysis. So here we'll do aluminum 4T3 against a stainless steel 316. And here you can see the corrosion rate and the galvanic corrosion rate. Next we're going to look at some materials. So here, for example, you can see data being pulled from the Corrosion Djinn database, and here you can see the results. You show the material density for that material, and then any self-corrosion data in different environments. In addition, I've created some custom materials. So here you've created a custom material called custom example, which is a substrate with a designation, and electrochemical equivalent, and then importantly, I have ticked this box so we can export this material out to the Siemens integration license. Next, I'm just going to look at some polarization curves for this material I've set up. So if we come into here and look for a custom example, we can see that we've created a material in 3 different environments: the 12%, 3.5%, and the mill standard. If we look at the 3.5%, we can see that it's exportable to the next license, and this would be the polarization curve we've used for our custom material. Next, say if we wanted to use our data inside of NX, we would simply go to Organization Admin, Toolset License, and this is where you're able to export your license to be used inside of NX and CCM+. You'll notice here as an expiry date, this is equal to the expiry date of your Corrosion Djinn Standalone, and also there are some toolset MAC addresses. These are used when you are exporting the data to be used in CCM+, as CCM+ uses a seat or seat or machine-based licensing approach. Here I will generate the licenses, and here you can see I've downloaded instantly the toolset licenses to be used. Now that we're back on my desktop, we're just going to look at moving those files into the NX installation directory so that we can see our custom materials inside of NX. So here I have extracted the license file folder. Inside we can find those 4 files we mentioned previously. For NX we only need these 3 files. So what I can do is just copy these files. Here I'm going to go to my NX installation. So for me it's program file, Siemens, and then the NX version. And then to design tools, corrosion. And here you'll find the files that are the same. If I was then to paste those files and replace the existing files, these files are now usable inside of NX. So we'll look next. Now that we're inside of NX, we're just going to open up an assembly. This is a simple assembly containing a few materials I'm judging. So here we'll start by looking at what materials we've got currently. So if we'll just select this long piece, we can see this material is assigned with a stainless steel 316. And then if we look at this connecting piece up here, we can see this material is assigned with the aluminum 20x4T3. If we want to, we can run an analysis on this. If I go to HT3D Tools, Corrosion Risks, selecting the material we're interested in this case the whole assembly, and then press Apply, and then we can run the analysis. And here we can see the touching pair between these two materials, resulting in a 4 from our standard rating and a pretty high corrosion rate between the aluminum and the stainless steel. If we want to make some changes to this, we could go into our tools to assign new materials. Let's say we replace the long piece with our custom material. If we go to assign a material, here you can see that I've chosen a user material library. I've gone for inside my install directory, corrosion, and then the substrate.xml file I created previously. And inside of there I can see all my custom materials, organized by name. For this case, I will choose my custom example material I created previously, and apply that material. Now that material has been applied to the long piece, which you can see here, we can go back into looking at the whole structure, into the corrosion risk section, and then rerun the analysis. You notice this is grayed out to show that the material has changed and the results are out of date. So here you can see there's been an instant change. Now we've got custom example. There's a lower corrosion rate, and instead the custom example material is now the anode in the partnership. So that's just a brief example of how you can easily take your materials from your custom Corrosion Djinn Analysis database and then run them inside of NX with a click of a button.